Mass-to-mass stoichiometry, and this is where the fun starts. Okay, to ace this, you will need to be able to calculate formula of molecular mass like it's your second nature. You will also need to be able to convert between mass and mole like a pro. When you are able to do both of things, then we will have enough cognitive load to understand the process that's about to begin. Okay, so stoichiometry is just a big word referring to the relationship between the relative quantities of a substance taking part in a reaction or forming a compound, typically a ratio of whole integers. Okay, so basically, stoichiometry calculation is using the ratio given by a balanced chemical equation to work out the unknown quantity. Now, mass-to-mass stoichiometry, so it's one type of stoichiometry calculations. Write the full balanced equation. Calculate the amount in mole of the substance with the known mass. Use the mole ratio in the equation to calculate the amount in mole of the substance needed. And this part, really only this step 3, is stoichiometry part. Okay? And the last part, we convert it back from mole to mass. Okay? So just you know that when we say amount, we mean mole. Okay, we need to clarify that. Here's an example. Okay, what is the mass of green rust formed by 70 grams of iron? And here is the reaction equation. So first of all, always check if the equation is balanced. Here it is actually balanced for you. Okay, so what is the target substance? Green rust. It's referring to that iron 2 hydroxide over there. Okay, so the chemical equation gives a ratio of 2 to 2. So basically it's 1 to 1. Now let's start the process. We first convert known mass to mole for iron. That's 70 grams over the molar mass of iron. I said we need to do this like a pro. Okay, so we work out the mole of iron that's actually participating in this reaction. Then the chemical reaction gives us a ratio of 2 to 2, which is 1 to 1, which means that the unknown substance will also be the same amount of mole because it's 1 to 1 ratio, right? One iron gives one iron hydroxide. 2 ions will give 2 iron hydroxide. So it's a 1 to 1 ratio. Therefore, the unknown amount is 1.2533 as well. But it's not finished yet. The question asks for the mass of iron 2 hydroxide. So we need to convert it back to mass. All right? Okay. Yeah. So at the beginning, you probably want to refer to this process diagram a lot until you can do this as if, again, it's your second nature. Okay, so we usually start with the mass of the known substance, work out the mole of that substance, then use the coefficient given by the balanced equation. We ratio out the mole of the unknown substance. And in the last step, we convert it back to the mass. Why do we need to keep doing this process? Is, as I said before in the previous session, mass is something that we could measure in a lab. And mole is something really we barely really be able to count by moles because 1 mole is too big of a number for anyone to count. But actually, chemical reactions happen based on number ratio, not based on mass ratio. So we have to continually doing this mass mole conversion so that we can actually use a balanced equation to work out the unknown amount. Okay. Now, your turn. You probably want to pause here to give yourself a try. Right? Same reaction. Now this time we're looking for the amount of oxygen required to actually produce iron 2 hydroxide. Okay. Now the process goes again. We first need to work out mass to mole. Known mass, work out the mole of the substance that we know using the ratio. Here the ratio is 2 to 1. Okay, in mass. If 2 moles is 1.2533, then 1 mole means that we need to divide by that amount by 2, right? Divide by 2 to work out the unknown amount in mole. And lastly, we work out the mass of oxygen that's actually needed. Okay, so as you probably will see, with mass of one thing and a balanced equation, you'll be able to calculate the mass of any species in the reaction, right? We only need to know one to work out the rest of the substances, as long as the chemical equation is balanced.